Okay, resolve because somebody, it's David Nguyen, asked me if I can find the index of the minimum element of an array. Although this is technically a little different because it's the actual, what do you say? It's the element itself rather than the index. It's literally the same intuition. So we can see that it is a log n problem and it is a sorted array, which means binary search. So let's just be quick and say int left equals 0, right, is equal to nums dot length minus 1, while left is less than right. I don't know. I'll just say equal to. Less than right. And basically, if a array was just fully sorted, then the element on the left would just be, how do I say, the element all the way on the left would be the min element. So we need to see how much it pivoted away towards the right. So if we say like our middle is like our pivot, like could it be over here? We're just gonna like binary search the pivot basically. So we'll just say int mid is equal to um what? Left plus right minus left divided by 2. This will pretty much never out of bounds you. There's some cases where right plus left divided by 2 will out of bounds. This one will never do that. Yay. I forgot why it works. It just does. So how do we know our middle is a proper pivot? Well actually, how do we know if this thing is correct? Like, we just say if nums left is less than nums right, then we know we found a proper area, so we can just return nums left. And then just to be safe, might as well just return nums left down here. So how do we know? If this isn't true, then what gives? Like else, if num's middle, well, how do we know if we need to check the left side or the right side? Well, let's look at these test cases. It will be on the right side if this is... Ooh. Okay, that checks out. Hypothetically, if it was, let's say we started with 0, 1, 2, 3, 4, 5, 6, and then it became something like, it became like 1, 2, no, it wouldn't be that, it would be like, let's just say 0, 1, 2, 3, 4, 5, 6. Okay, we'd start middle and then we'd move right, but when would we move left? Well, 1, 2, 3, 4, 5, 6, 7. So we'd start here, and then we'd say move right. So maybe I actually need a 0, 1, 2, 3, 4, 5. So I start here, and I check my bounds maybe. I think, do I check my bounds? So else if, ooh. So after this condition, we know for a fact that num's left is greater than or equal to num's right. And if that is true, so how would I want to shrink it to the... Maybe if the middle hmm, if the middle is okay, maybe I'm thinking about this wrong. I have to think about this. Let's let k equal like number like pivot, and then we know position, the index is equal to like nums what is it, like length. No, it would be 0 plus k oh, remainder nums dot length, but honestly k oh yeah, but k will never, so we could just simplify it to this, and then we know k is gonna be from 0 to, well, not 0, it would be 1 to n, it would be like 1 to like n. And let's just say like mid is equal to temp k, like our current k. Okay, no, never mind. That's a really weird way of thinking about it. I'm gonna keep going with this one. Okay, somehow this seems like a really good else. We could say else. We could say else. Left is equal to like mid plus 1. We can say else if I want to do something with nums mid, I think. In this case, if nums mid is there a time mid will ever be greater than nums, right? Yes, here. So if less than or equal less than nums, right? Mid left is equal to mid plus 1, else right is equal to mid minus 1. Let's just do mid. Oh, 3. Alright. So in this case, mid is not, so right shrunk down. Wait. Is that it? Oh, yeah. Okay, well, that's how you do it. If you want the index, you would just say return left here, and that's how you solve the n log n time. Yay.